After you know how to convert to and from scientific notation and what exactly scientific notation is, then it's important to also know how, when given a number in scientific notation, how to do operations. So how to do addition, subtraction, multiplication, and division. So what we're going to look at first is how to do addition and subtraction in scientific notation. The most important thing about doing addition and subtraction in scientific notation is that your decimal points, so therefore your actual place values, are lined up. So what I'm going to do is go through these steps with our example problems. So our first example is 2.61 times 10 to the power of 6 minus 3.2 times 10 to the power of 5. I need to first write both numbers in expanded form. If you see here, I actually have graph paper glued down. That's just so when I align my place values, you see how important it is that they are exactly lined up. So first, I'm just going to expand both these numbers. There's an exponent of 6, so that means that I'm going to move my decimal point 6 place values to the right because it's a positive 6, so we're making a bigger number. I have to fill in zeros where there isn't anything, and then I need to write down the number. So my number is 2, 6, 1, 0, 0, 0, 0. Then I need to expand the other number. My other number is just 3.2 times 10 to the 5th. So my exponent is a positive 5. So I move my decimal 5 spaces to the right because we are dealing with a positive exponent. So we're making a big number. I put zeros as placeholders. So then I have 3, 2, 0, 0, 0, 0. When it's perfectly spaced out like this, it makes it a lot easier to line up the decimal points, which is my second step. So it says align the decimals and fill in the blanks with zeros. This second part is really important for kind of, it's tying together steps 1 and 2. So we already filled in the missing spots with zeros. So I'm going to put a decimal at the end because that's the assumption. If there's no decimal point present, we know it's just a decimal right at the end. I'm going to align them. So what I'm going to do with my 320,000 is I'm actually going to write it backwards so that I am ensuring each digit is lined up exactly how it should be. Then I've finished step 2. And step 3 is to just do the addition or the subtraction. So this is a subtraction problem, so I'm doing subtraction. 2 can't take from 1, so we have to borrow from the 6. And then my fourth step is to return to scientific notation. So clearly this is a giant number. We're going to have a positive exponent. I need to move my decimal 1, 2, 3, 4, 5, 6 places. And my result is going to be 2.29 times 10 to the power of 6. It's going to be the same exact way for addition, except for instead of doing subtraction, you just do addition. So this time I'm going to show you an example with negative exponents. because we just want to be able to practice going to and from scientific notation with negative exponents. So I'm going to do my first step, which is to write both numbers in expanded form. This is a negative number, so it's a negative. We have this negative exponent, which means I'm making a tiny number, which means my decimal's moving to the left. 1, 2, 3 spots. So when I write my number here, I have 2 zeros, and then my 4 and my 8. I'm going to do the same thing for the other number. This one is a -5, so I'm going 1, 2, 3, 4, 5, which means there's going to be 4 zeros before that 5, 9, 1. So I'm just going to put my addition sign here. Decimal 1, 2, 3, 4, 5, 9, 1. And it's super important now when we're doing this setup. I'm actually going to rewrite both of these because I need my decimals to be aligned. So instead of going from like making sure they're aligned going left, like we did for the subtraction problem, when we have these really teeny tiny numbers, we want to make sure their decimals are aligned. And we can do that just by writing the numbers lined up on this left side. So I can just write normally from left to right. So the step where it was fill in the blanks with zeros is super important for when we have a problem that looks like this, because there are zeros continuing forever after this decimal point. So I need to fill in these with zeros. I get 1, 9, 5, 8, 4, 0, 0, decimal point, because all I did was add down. And then I'm returning the scientific notation. So scientific notation needs just 1 digit to the left of my decimal. So in order to have that, I need to move it over 3 spaces. This is a tiny number, so that's a -3. So I have 4.8591 times 10 to the -3.